Good day to you. In today's tutorial, we shall be looking at Vieta's formula for quadratics. We will derive the formula and we will also apply it. So make sure you watch to the end as we take you on the ride. First, we are going to start with the general form of quadratics. The general form of quadratic equations is ax squared plus bx plus c equals to 0. We are going to call this equation 1. Now, we will let the roots of this equation be alpha and beta. That is, x should be alpha and beta. This simply means that x minus alpha equals to 0 or x minus beta equals to 0. Combining the two in product, we have x minus alpha multiplying x minus beta to be equal to 0, and expanding this gives x squared minus beta x minus alpha x plus alpha beta equals to 0. Rearranging to have alpha first before beta, it gives us x squared minus alpha x minus beta x plus alpha beta equals to 0. Now the two terms in the middle have a common factor which we factor out to give us x squared. Minus can be taken out and we have alpha plus beta in bracket with x also factored out plus alpha beta equals to 0. Let us designate this equation 2. This is another form of quadratic equation, and it can be seen that alpha plus beta here is the sum of the roots we started with earlier, while alpha beta is the product of the roots. What we want to do next is to derive Vieta's formula. However, when we look at equation 2, the leading coefficient is 1. So we are going to need to write equation 1 so as to have a leading coefficient of 1. And that means we divide through by a. Dividing 1 through by a is going to give us x squared plus b over ax plus c over a equals to 0. We shall be calling this 3. And finally, we compare 2 and 3. In comparing 2 and 3, the leading coefficients are both 1. So we move to the terms in x. Comparing the terms in x, from equation 2, we have minus times alpha plus beta equal to b over a. Then multiplying both sides by negative 1, alpha plus beta is negative b over a. Similarly, comparing the constant terms, alpha beta is c over a. This means that the relationship between the two forms of equation is that the sum of roots, alpha plus beta, is negative b over a from the general form, while the product of roots, alpha beta, is c over a from the general form. This is what is known as Vieta's formula for quadratic equations. Another important thing to note from this other form of quadratic equations is that when we have the sum and product of roots, then the quadratic equation is x squared minus sum of roots times x plus product of roots equals to 0. This is an important finding. Make sure you note it down somewhere. Now let us move to the applications of this formula. derived so far. Application 1. We are given the roots of a quadratic equation to be -1 and 5, and we are to derive the equation. To get this done, if the roots are alpha and beta, it simply means alpha is -1 and beta is 5. So we will need to find the sum of roots and also find the product of roots. The sum of the roots alpha plus beta will be -1 plus 5, which is 4. While the products of the roots are -1 times 5, which is -5. These values are then substituted into the form of quadratic equations derived earlier. X squared minus sum of roots times x plus product of roots equals to 0. And the required quadratic equation is x squared minus 4x plus minus 5 equals to 0. And finally simplifying to x squared minus 4x minus 5 equals to 0 as the required quadratic equation. Application 2. Find the sum and product of the roots of the equation 2x squared plus 5x minus 4 equals to 0. The given equation is 2x squared plus 5x minus 4 equals to 0. Here a is 2, b is 5, and c is -4. Therefore, sum of roots which is alpha plus beta is minus b over a, and that is minus 5 over 2, while the product of roots that is alpha beta is c over a, and that is -4 over 2, which is minus 2. So the sum of the roots is minus 5 over 2, while the product is minus 2. Application 3. Find in standard form the quadratic equation whose sum of roots is minus 3 over 5 and the product of the root is minus 5 over 3. Here the sum of the root is minus 3 over 5, while the product is minus 5 over 3. Then we are going to substitute into x squared minus alpha plus beta s, that's the sum of the roots times x, plus alpha beta, the product of the roots, equals to 0, to give us x squared minus 3 over 5 x plus minus 5 over 3 equals to 0. Then when we tidy up the signs, we have x squared plus 3 over 5x minus 5 over 3 equals to 0. But we have to write this in standard form. So we multiply through by 15, the LCD of 5 and 3. This gives us 15x squared plus 9x minus 25 equals to 0 as the required equation. Here is another math tutorial on quadratics from us. We believe you enjoyed it. Let us know your thoughts in the comments box. Do ensure that you subscribe to the channel so that you can get more from us and help us share the video. Thank you. Till we see you again. Have a lovely day.